In this session, we are going to discuss about linear regression in machine learning. Hope you already know about linear regression. So, what is it? It is a supervised learning algorithm in machine learning where we need to predict the next element of the given data. For example, let us take a single variable, maybe no, suppose the profit element is there. Okay, let's randomly take this profit. Okay, from 2005 to 2023, the profits are given here. Okay. Then, if we have only one variable, how do we predict in a normal scenario? For example, if we let us take weather forecasting for the last 7 days, if the weather is like continuously raining, there is a lot of chance that next day also it's going to rain. In the same way, how can we predict that the next day weather forecasting based on the previous day's weather, right? So we are taking the average of the weather for the last few days. Okay. In the same way, since we have the profit is given for the last 2005 to 2023, these are values. The average for these values is 72. Okay. So the 72 is the next prediction, provided we don't have any other information. Okay. We don't have any other feature, and we have to predict that one. So we have no other option but we have profit. So it is a common practice to take that. So the average is this one. Okay. Presume that the actual prediction for 2024, if it is maybe 94, okay, then what is the average of the, I mean, the prediction, what we have predicted is 72. Right? See, in this way, we can clearly see that there is a difference between the actual profit and our predicted profit. The difference is this 22, 94 minus 72 equal to 22. Okay. This is the error, right? Error element. So, in our prediction, the error has been occurred with the difference of 22 points. 22, maybe whatever the units. If it may be, 22 crores or something like that, presume that it is in Indian rupee, it is 22 crores, presume that. Okay. If we take this one, the prediction for 2024 is 72. And 2025 also the prediction should be 72 only. Okay. If we just take the values to back instead of front, for all the values of the prediction from 2005 to 2005 to 2023, the average is 72 only. That is the predicted value for the given actual values. If you take that in a proper chart in Excel sheet, okay, see, this is the average. That is nothing but the average predicted value. But the actual values, these are spreading from 23 to 99, right? You see clearly the difference of the profit between the error, sorry, the expected, the predicted value and actual value are so much deviated from the actual, right? The difference between these two lines is the difference, nothing but the error in the prediction. Okay. How can we minimize this prediction? I mean, the error. Okay. That's what the question is. Okay. This is the prediction problem. The machine learning algorithm, it should address. That is what the target of. Okay. Our prediction should be close to accurate. Means the actual value, actual profit minus predicted profit should be zero, right? Okay. This is what the aim is. But in real time, in the real case, if any human being, if he predicts anything, will it be accurate of what is the percent of uh, the prediction should be equal to actual? If it is absolute zero, then it is not a meaningful expectation, meaningful work, right? So it should not be, it is nearer to the actual. Then it should be a human expected or human predicted value. It should be like a human prediction in the machine learning. Okay. It should not be absolutely, if it is great, but the target is like, it should be actual versus actual minus the predicted should be zero. That is the ideal case. Okay. And we were given, we have earlier, we have profit. Now we were given sales also. Okay. And how the sales is influencing the profit. Is there any influence in profit or not? First question. And if so, how much it is influencing the profit? So the problem for our machine learning algorithm is prediction problem. That's what we are dealing with now. Okay? Prediction problem. So this prediction problem is part of supervised learning algorithm. Okay, supervised learning. This is right. Supervised learning is part of, we have the machine learning, and in the machine learning, the learning is supervised and unsupervised and reinforced. Okay, learning. In this category, this regression is the word linear regression. Regression. And this regression, it solves the prediction problem. Okay. It is any kind of prediction. Okay. For this, what we are doing is we are taking a prediction problem and we are solving it. Okay. What we are doing is we are building a model that solves a prediction problem. Okay. The model, how to build. Okay. So till now, what we have seen, we have a feature or variable, we have profit and we have predicted and we got some error, right? Now let us take sales is there, another variable sales. Now what is dependent and what is independent here? In this case, in linear regression, we have two kinds of variables, right? That is dependent, independent. Okay. Dependent variable is profit. What we want is this is profit. Why? Because sales influencing the profit. So sales is independent variable and profit is dependent variable. Otherwise, we call this is y and x, okay, where x is independent and y is independent. Let us create one chart for these two variables. Okay, we have created a chart. This one. Okay, this is the data for that. Okay. And this each and every point. See, earlier this is profit actually. This is spread of profit only. Okay. Each and every point it belongs to profit. This is profit, and the on the y-axis it is sales. Okay. See the how much is this? Sorry, x-axis it is sales and y-axis it is profit. The profit is how it is spreading. It starts from 23 to 23 to starts from 23 and it is ending at 99. Okay. It's an error. If you see that what sales is there at 23, around it is 211, right? 211 is there. And from 211 to it is spreading this one. Okay. This is the point. And if you see the trend line, this one, if you see this, it is close to the data points, the profit points, right? In the earlier, in the earlier chart, it is nowhere which is will see the expected value. Okay, this is the average. Okay, this is the actual values. How much ever it is there between this and this one. But here, if you see this, the trend line, the data points, this is the our predicted. Okay, these are the actuals. See how it is close to this one. So the error has been minimized. Let us compute how to calculate this influence. Okay, how much it is influenced. So the profit before the error before having the sales variable, and this is what actually this is the average of profit. If you see this the average that we have taken 72.74. This is the average. Okay? And x value is there. We have x sales values there. And if you take, we have some small computation is here, so that actually we can calculate some metrics. Okay, what is meant by metric? Metric means metric. It's a measure. What is the measure means? What is the measure that we can predict the accuracy of the model? Okay, what we want is accuracy, right? Accuracy. To measure a length, we want meter or centimeter, something like that. There is a metric for that. That is a metric. To liquid, we have liter, milliliter, something like that, right? In this way, for temperature, we have Fahrenheit or centigrade. So in this way, to measure our accuracy, we have a metric. Okay, that we have that is called R square. R square is the metric for us. And this is a common practice to measure the accuracy of linear regression using R square. We have other measures also, RMSE, root mean squared error, that we will see. So we have two variables here. If you see this, the relationship between these two variables, that we, if you observe this one, okay, the relationship of this chart, it is in linear fashion, right? It is in a linear fashion. So I think everyone knows about mx plus c. That is the linear equation, right? We have y equal to mx plus c. What it is giving is, if we wanted to know y, this is a function mx plus c. Okay, where m, everyone knows about this one. Mx, x is there, and c is there. What is c here? C is a constant, and r uh, centroid, and m is mean. Okay, m is mean value. That is slope. M is slope. What is slope? C is constant, and x is the value that we know. If we have, if we know about the values of c and m, we can, we have x already. We have x values. This 20 to 11 to 457. Those are, we have separate minutes. So many values are there in between. So for each and every x value, we can find out y value. That's what the equation tells. So let us go through a little bit of computation. We have mean, we have to figure it out mean values of x and mean values of y. Okay, this is a sum for x and y. This is a mean for x and y. And let us take x minus x bar. X bar is nothing but mean value of x. Y bar equal to mean value of y. And take these two values and take sum. If you take the sum, it will be 0. If you take this one, it is it is equivalent to 0. Okay, it's these values are 0. It's 0. That's all. Okay. That is why we let us take this one as a squares of this one. Okay, let us take a multiplied by b also. This is xy x bar minus x bar multiplied by y minus y bar. That's what ab indicates. And take x square also, sorry, a square also and b square also. Here, what is indicating? What is b square? Means if you take b, this one y minus y bar, this is what actually? This is the mean of this one. This is a common mean. Okay. This is the earlier error. This is the mean, and the actual minus. This is actual minus. See, this is actual, and the mean value of this one 72. This is error, right? This is this value. If for all x values, this is the error values of y minus y bar. Okay. We have the reason for taking the square because the total amount should not be zero. This is the total error. If you see this, this is the total error. Okay. This error should be because this is actual minus predicted. This error should be minimized. That's what our target. Okay. This is the total error. I have taken this one. This total error called SST, sum of squares of total. Okay. This is the this is square values, right? Y minus y bar. Okay. And that is the error. Okay. This is what the total error without having x value. We have not considered x feature in this. That is sales. When we take this x also, in that case, what we have to do? We have to use y equal to mx plus c. This is the linear equation, right? If you take this one as a consideration, what we have to figure out is m and c, both of them, right? So in this case, let us calculate c and m. So this m we have calculated and c also we have calculated using this formula. M we got 0.301763 and c also c where mx will y equal to mx plus c. If you take the equation c equal to y minus mx, right? Obviously, and m equal to sum of ab by sum of a square. This is the formula. You can just check it out for slope. Okay, slope of a line or m or slope. Okay, slope of the line. And this formula, if we interpret that, we will get this value. And c we got minus 25.0554. This is the C1. This is called coefficient. M equal to coefficient and C equal to intercept. This is intercept. Please remember this one. And if we told already, we have C and M, we can calculate Y value, right? So if we take that Y, if we interpret all these values, we will get this Y value. See, this is the formula where I have given Y equal to mx plus c. In that case, we have calculated Y. This is Y predicted. And this is Y predicted after considering this Y. This is predicted after considering X value. This is the value. I mean, actually, this is the Y minus Y bar. This is the value without considering X, right? Sales. This is simply considered Y taking out from the difference of a mean minus actual value. That's it, Y value. And this is the predicted basing on Y equal to mx plus c. So this is the predicted value and the Y actual value is 23 and actual minus predicted. If we take that and square it, this is the thing. Okay. Now this is the updated error. Okay. The first error is this much, this color, okay, this color, and updated error is this one, right? So updated error, that is called sum of squares of error, and this is the total error. This is sum of squares of error. Okay. Now this is called And if you take out this one minus this one, this is the remaining error, right? This is called error reduced. This much error earlier, 11,015.68 is the total error. And the current error is 1,943. If you see that, there is a great amount of error that has been reduced. How much error has been reduced means this minus SST minus SSC, right? So this error is called sum of squares of residual. So this is the residual. So how much error has been addressed means how much error has been rectified. Okay. So that is equal to 9,072 SSR upon SST. Okay. So this much error has been reduced. If you see this one, this divided by this one, this much error has been reduced. So this is what R square means. Okay. R square is coefficient of determination. This otherwise we call this is a linear regression metric. This is a metric or linear regression. Okay. So if we say if it is actually there is this for cross checking. If it is no, this is R square. Actually, see if it is R square is 30%, at rest is 30%, the error remained is 70%. Okay, it is one minus that at rest. That's it. That is the remaining error. So here, how much error we have? Still, it is one minus this one equal to one minus this. So this much error has been still left. If you take this one as a percentage, it is 17%. Okay, that's what it is 70%, right? So this is what the linear regression gives. So we got the model. This is called the model. Okay. So what we have got or what we have obtained here is y equal to mx plus c is the linear regression equation, where we have c is intercept and m is coefficient. Oh, okay. Okay, it's nothing but intercept, and this is slope, right? It is slope, and it is constant. The other, it's a common terminology. So this, if we take this one, and for every x, we can calculate y, right? If we interpret this one, what is the x value? Y equal to, let us take y here equal to, what is m here? M is minus 25.05554. This is m. And what is x here? What is any x? Okay, we can take any x. Multiplied by x. Okay. Plus c. What is c here? We got say c equal to 0.25. Okay, m is different. So like minus 25.0554. And this one is not this. M expressed m is 0.301763. Since it will throw error, if we will give like this and give now, this is the equation what we have. And in this equation, for every y, for every x, we can calculate y. If you take this one, interpret this, all the x values, for all the x values, for 2.411, you can interpret, we can just give this value. In this, if we give 211 equal to this one. So instead of x, we give 211. Okay. This is going to be the y value of this equation. This is in this equation we can fit. For any new value, we can give the x value and it will give the output of the equation. That is nothing but y value. This is the prediction, right? What we are giving is we have built a model based on a mathematical equation using linear regression. And this is giving y value for each and every x. See how much near this value with the actual. This is 38, right? Let us see the actual values. This is our prediction. So there is an error, right? The profit actually is 23. But how much we got? 38. Okay. This is the predicted, right? 38 we have predicted. In this case, this is actually our prediction. And let us see how much, this is the error is not that much. But earlier, how much it is the error? It is minus 49, right? This is what the error. So this is a huge, it's not even a positive value. This is the error. And the predicted value here, it is 38. So this is somewhat okay. Okay. So the accuracy, it indicates, I mean, it's not very far and it keeps on changing. If you see this, the predicted value for this one, it is 112. Using this value, it is 133. This is the actual value. Sorry, it is 99 here. The predicted value is, we can just take any, for this value, we can just take 457, right? Let us take 457. How much is the profit? 457. It is 112. Okay, we got 112 value. Let us check that. It is our prediction is 112, whereas the actual value is 99. Still, it is different. I mean, difference is there, but it is far better. Okay. The actual value before that, the prediction is how much it is? It is 72 only. Okay, and the difference, the error is this much. Y minus y1 equal to 26. Okay. In this way, we can calculate that value. The same thing we will let us do it. Now, let us implement the same thing what we have worked in Excel using a mathematical equation using Python. Okay, we have to import libraries as usual. Import pandas as PD, import numpy as np. There we go. Okay. Let's create a data frame for a data set PD dot read underscore cb, read underscore csv. We have a data here, have a data saved in Excel sheet, sorry, in TXT file. This is the CSV, TXT only. It's not CSV. That's why we have to give delimiter TXT. Let us give that and take that data. Not delimiter equal to TXT. Let's dump it. The equal to, now the data looks like this. Okay. So how many values that we have? Only 18 values, 18, I think 0 plus. That is 19 values. Let us take that information. df.info. We have total 19 not null values. Okay. We have data type float is there for two. I mean, both of them. Okay. So there is a separator is there. Still, it is not showing. It is not accepted, right? So decimal, it is not decimal delimiter. Let's do that. Delimiter into this. Delimiter into There are two values, two features that we have, sales and profit, right? We have taken in form. And now from SKLN, we have to import SKLN from SKLN dot linear model, import linear regression. So linear regression. We have linear regression. Okay, we have imported linear regression and model will take that model to you have taken that linear regression to model. You have taken that to model. Now let us fit that immediately. We have we need x and y separately, right? Because x and y it should fit in the equation of y equal to mx plus c. Let us take that value separately. What is x equal to df of sales, right? Let us take sales. Let us take these values. Dot values. We'll take a mid values. Because that we should be values are little from else. Now how the values are looking like this. This is this. So because I want it in a different format, because it should fit in the formula of y equal to mx plus c, I want it should be transpose. Y should be okay. Y should look, y is looking nice only. So x dot values that we have and y it should come in. Let us take x is that one, right? Into y equal to if dot array df of profit, right? So, and x should be reshaped. Right? I need to reshape these values. Let us take that to reshape x equal to and p dot array of of sales. We have to reshape it. Not reshape. So this is actually what we are doing is transpose. Now, if you see x, these values look like this. Okay. Okay. Now, what I do is I need to take the model equal to linear regression, right? Yeah, model equal to linear regression. This is sufficient. Model equal to linear regression right, right? Now, model equal model dot fit. We need to fit x and y. Okay, x comma y, and model is fitted. Now, check the regression. What we need to do is, it is fit. The model has been fitted. So, what is the uh, R square values that we got? I think this one. Okay. This is R square equal to 82 point. This one, right? So 82%. It should come there. We'll check whether it is coming or not. Okay. Count. Now, skeleton. So, of x comma y. Now, R square equal to 82.36. You got it right. Exactly, we got the same value which we have calculated using Excel. Okay, this is 82%. So this is the metric for us. So this is the accuracy metric for linear regression metric, right? This is one. And we have also exhaustive. Exhaustive. And let us calculate intercept also. Model dot intercept. This is minus 25. Okay. What else is there? We want coefficient. Model dot coefficient. It is 0.30176. Once, yeah, 176. Okay. So let us check the calculated values for that m and this one. What is that intercept? Intercept is nothing but c. Okay, it is c value, and the coefficient is nothing but m value. Okay. Let us take what we have got in Excel. What is the m value? Here, this is right. This is what the values that we got. So, yeah, we got this one 301. We got exactly the same coefficient m value here, and C also we got minus 25. Okay, here also we got minus 25, right? So in this way, we can get the we already got right m and c values we got. Now we can just interpret the same thing for getting y value. For each and every y value, we can calculate this. Yeah, this one. And there is another metric that is called RMS, root mean squared error. Okay. So what it indicates is the error between the actual and predicted. Okay, that is the error. So if the error should be obviously minimized, right? If there is a less error, then the model is better, right? So in that also, let us calculate that from sklearn dot metrics before mean squared error. Yeah, mean squared error, right? We want mean absolute error, mean squared error. Now let us see that MS equal to mean squared error. Now MSC. So MSC of. We have to calculate for this y predicted y value. So y predicted. So we have not calculated y predicted. That's why. So how to take y predicted value in this? So before this, what we have to do is you have to calculate y predicted, right? So model coefficient y predicted equal to y underscore predicted equal to model dot predict of x. For each and every x, we need to predict the values, right? So y predicted we got. What are the y predicted values? These are the y predicted values. So if we take the difference between this and that, right, that is the error, the difference between y and y predicted. Yeah. That's what the y and y predicted. This one. So 102 is the mean squared error. Okay. And what we need to have is root mean squared error. So what should we do for that? Root mean squared error. RMSC we want. RMSC equal to mean squared error MSC is of y comma y thread y fifth comma square equal to false. Okay. Now RMS. So this is 10. Okay. RMSC we got 10. So this is the low. I mean, actually, it means the error is still there. Maybe it is not. That's what it indicates. It is 10, but it is not significant. It is still it is tolerable. So the accuracy, how much we got, R square is how much we got here, 82%. So R square is the, I mean, expensively good, but if it is beyond, I mean, above 80 and 90, it is highly preferred. Still, it is okay. This way, what we got is 82% is R square. Okay. R squared is 82%. 82 point something like that. That point maybe 3 something like that. 82.354. 354. So this is what the computation using mathematical way for linear regression. So in this way, for each and every x value, for a new x value, we can predict using this equation, right? So we got, y equal to mx plus c. So we have m value, we have c value, and so we can interpret for each and every x value what is the y value. That's it, right? So we got all the values. So here, what is the value for this? Y equal to, for m is what? How much we got? M we got is m, right? It is 0 this form. M into x, x plus c. What is the c value we got? This is the minus 25, right? This is the value. So this is the equation for linear regression. Okay. This is the mathematical way of explaining what we have, the modeling that we can build using sklearn. That's the way of, train test